All right, so hello everybody, welcome back. So in this video, I'll begin to illustrate to everybody how to work on in terms of the implementations of the double-threaded binary tree. So we'll begin to work on that step by step. So as what we have mentioned for the double-threaded binary tree, okay, we need to get actually their in order predecessor as well as the successor. So that means to say, you will be going to work on both their left and right left subtree as well as the rightmost pertains to this one. So what we'll begin to okay, just a minute. Okay. So here then in this, we do have seven elements. For example, we'll make it here so that it will be easy to implement. So, first thing first, that you will begin to create the tree. So it will be a complete binary tree. The same thing that you will begin to insert from leftmost down to the rightmost, and then make sure that it is actually in order level. That means to say we'll have to work on from level by level. So left to right, and then 53 will be inserted into the leftmost, and 24, even that it's not being arranged, since we're not observing the binary search tree anymore. Okay, 9 will be here, then 16, and then 29, and 86. Okay. So we're done with this one. The first step that we'll begin to work on after you created the complete binary tree, you have to work on with the in order traversal, because the in-order traversal will be your aid, especially for getting the in-order predecessor and successor, since we are trying to make a thread for both the left side as well as the right side of this one. So the same procedure that we will begin to create three bucket, then five bucket, and creating a thread flag, identifying one and zero, the same implementation. However, there will be a leftmost and rightmost for this one. And you can implement already for the deletion, of course, the in order successor and in order predecessor. So let's take it one by one. Okay. So in order traversal, as what we have mentioned, that is left, then root node, visit the root node, and then the right node. So it will become 76 left. There will be left, which is will be 9. And then the root node will be 53, then 16. Backtrack. We're done with this. So this visit 76, and then we cannot visit 24 yet, since there will be a left node will become 29, then 24, and then 86. So this is your in order traversal for this implementation. So what you will need to do after you create, you achieve, or you were able to see, the in order traversal, you will create the bucket, the three bucket already, so that you can create the thread by identifying the in order successor and predecessor for this. So for this 176, okay, three bucket, and then 53. I know it will take takes a long time, but it's okay. You can do it. Then 9, and then 16, and then 29, and then 86. So for this one, we can identify already the in order successor, in order predecessor already for this one. So when we say in order successor, that will be the right most, and the leftmost will be the left side of that given node will be actually the in order predecessor, and the right side of that particular number will be the in order successor. That's how you will work on that. So let's try to check first. Okay, let me just use another color so that you can definitely understand it all. So for the nine, let's try to check for the nine in order successor first. The successor will be 53, and the successor of 53 will be 16, and 16 successor will be 76, and 76 successor will be 29, and successor of 24 is 86. And then successor of 29 will be 24, and 86 is none. And then for this one, for the predecessor, the 86 predecessor is 24. That was done. So we're able to work on that already. Then the predecessor of 24 will be 29. So we're done with that. Predecessor of of 29 will be 76. So it's already being established earlier. And for 16, that is 53. So we're done. 53 will be 9. So we're done with this. And 9 predecessor is actually null also. So, respectively, we will begin to get, you will have to create five bucket already now, as you will begin to make a dummy node, and then you have to connect that one. Um, in terms of the implementation, it must be like this. I'm sorry. Let me go back. It will be like this. So 76, and then 53, 24, and then 9, then 16, then 29. I'm sorry, 29 will be here, then 86. So for this one, the same implementations that you will need to do. You have to connect this one still. And for the in order successor and order predecessor, it will be the same thing. However, you will begin to create a dummy node, as what I have mentioned, that we are trying to create a dummy node. The dummy node must be placed above. Um, okay. So the dummy node, this one must, the left child must connect into itself, and then the right side will connect into the root node. That's how it works for the dummy node. Since we're trying to check the in order predecessor and order successor in this one. Okay. So for your in order predecessor and successor, um this one must be connected into the dummy node, and this one also must be connected into the dummy node. So earlier, 9 connect to 53, then 53 connect to 16, 16 connect to 76, and then 76 connect to 29, and then 24 connect to 29, and then 24 connect to 86. And 86 has been established already, so that was done. So we will begin to create right now the um, identification of the, if it is 1 or 0, the thread flag. So 1 for parent to child. So what I have mentioned into the previous discussion, and 0 will be child to parent. So how can we work on that? So 76 connect to the parent to child, that will become for the successor, it will be 1. For the predecessor 1 still, Here then 1. This is 1. And still 1 and 1. And right now, leaf node will be 0, 0 also, 0, 0, and 0, 0. Why 0? Because that is child to parent node. And here then, that is 1, and that is 1. So this is actually the complete insertion operation of the double-threaded binary tree. And hopefully that is really clear for everybody. And in separate video, we will be going to work on with the deletion, especially for the double-threaded binary tree. So it's a bit of complicated. However, you have to work on that step by step since we are trying to work on with pertains to the algorithm. So thank you so much and see you there.